Hello, this is Ann Bear, and today I want to discuss with you a special problem type in section 6.3, problem type number 12. You will see one of these problem types for your written work assignment. So this video is particularly important because it's going to show you exactly the work I want to see for this problem type, and also how to go about writing your work down. So what we are going to want to do in general in this section when you're asked to solve a system of linear equations is you'll want to start with the augmented matrix, perform algebraic row operations to obtain the goal matrix, and this goal matrix is in row echelon form. The process of doing that, getting the matrix in row echelon form, is called Gaussian elimination. I've got the rows and the columns labeled appropriately. R sub 1 is row 1, R sub 2 is row 2, R sub 3 is row 3. And then I've done that for the columns as well. The goal is to get 1 in the column first, and then zeros beneath it. And then go column by column, starting with the leftmost column. Most of the credit on the test and the final will be given for algebraic row operations. That is, all but 1 point or so. That 1 point will be given for the answer. It's not the matrices that I'm concerned with or looking at, really. I'm looking for the algebraic row operations, although you will need to write down your matrices to determine what the algebraic row operation is that you need to write down. So how do we go about coming up with these algebraic row operations? Well, it depends on, from this goal matrix, whether you need a 1 or a 0. To get a 0, this is what you do, and to get a 1, this is what you do. I have started a list of tips for you. Feel free to add to this list. Some of the tips that you will want to remember and use are to copy over the rows you wish to keep first as you go from matrix to matrix. Then do the row operations column by column. Use your graphing calculator to do tedious arithmetic. Remember to use braces. Not parentheses, but the braces. There's a video here I want you to watch. It's called Solving 3x3 Systems with Gaussian Elimination. Number 2. In this video, the instructor uses a graphing calculator and shows how to use the graphing calculator to help you with the arithmetic for these types of problems. Then, when you get to the goal matrix, you're going to use the last row of the goal matrix to find z, and then use back substitution to find x and y. So let's see one of these problem types now. So the problem type I got for number 12, the problem I got is this. Use row operations to solve the system. Here's our goal matrix, copied over again. First thing, create the augmented matrix. How do we create the augmented matrix? Well, on the left side of the vertical bars are the coefficients. The vertical bar stands for the equal sign. And on the right side, we have the constants. So let's go row by row. This equation, we have 1 has a coefficient of x, -1 is the coefficient of y. We have 0z equals 4. In the second equation, we have 0x, so we put 0 in for our coefficient, 1y, and -1 is the coefficient of z, equals 3. In the third row, our coefficient of x is 1, coefficient of y is 0, coefficient of z is 1, equals 1. So now that we have our augmented matrix, we look at our goal. We look in the first column, starting with the 1. We always want to look at the 1 first and see if we always want to get the 1 first in order to preserve the structure. So we've got a 1 here in that first row, in the position that we need it. We also have a 0 right underneath it. We do not, however, have a 0 underneath that. We want to get a 0 there. So the only row we need to change, the only row that does not have the structure that we want, is row 3. We like the first 2 rows, so let's copy them over. So all I've done here is copy over the first 2 rows exactly. How do we get a 0 there? So let's go to our tips sheet. To get a 0, take the row where you want a 0 and subtract from it. So we want a 0 in the 3rd row. So we're going to take that row, which is row 3. So we have a capital R written down. I've written a capital R, sub 3 with the 3 off the normal line of writing a bit. And we want to subtract from it, so subtraction sign there. Now let's go read the second clause there. Subtract from it the element where you want a 0 times a row having a 1. The element where we want a 0 is 1. So we put a 1 there. Times a row with a 1 along the diagonal in that same column. So the row having a 1 along that diagonal in that column is row 1. So that's why we have a row 1, R sub 1. So now, how do we use this row operation on this matrix above here to fill in this last row here? What is this saying? This is really saying row 3 minus row 1. And we're going to go column by column, taking the element in row 3 and subtracting from it the element in row 1. So row 3 in column 1 is a 1, minus 1 in that column is 0. That's why we put a 0 here. Now we're going to look in the next column. Row 3 minus row 1. 0 minus a minus 1 is 0 plus 1, which is 1. That's why we put a 1 here. Row 3 minus row 1. 1 minus 0 is 1. 1 minus 4 is negative 3. That's why there's a negative 3 there. So we filled out that matrix. And our column 1 is exactly how we want it. So let's look at the goal. So in this column, we now want to make sure we have a 1 in that position, which we do. Lucky us. And then we want a 0 below it. Well, we do not have a 0 below it. We need to get 1. We want a 0 there. We like the first 2 rows. We're not changing those rows at all. We just copy them over. Exactly. We want a 0 here. How do we get a 0 there? Well, we take the row where we want a 0. Again, we want it in row 3. It doesn't always happen like that, but here it does. We wanted a 0 in row 3, so we write down R sub 3. And we subtract from it. What do we subtract from it? The element where we want a 0, which is a 1, times the row that has a 1 along the diagonal in that column, and that would be row 2. So that's how we get that row operation. So we are now going to apply that row operation to each column. So we want to take what's in row 3 and subtract what's in row 2. So row 3 is a 0 minus what's in row 2 is a 0. That gives us a 0. Going to the second column, what's in row 3 minus what's in row 2, 1 minus 1 is 0. Third column, 1 minus a negative 1, 1 plus 1 is 2. Last column, negative 3 minus 3 is negative 6. So now let's take a look. We have the structure we want in the first 2 columns. Let's look at the third column. What do we want? We just want a 1 in that position. Do we have a 1 in that position? No, we don't. We need to get a 1 there. How do we get a 1? Let's go back to our tips sheet. To get a 1, take the row where you want a 1 and multiply by the reciprocal of the element where you want a 1. So let's go back here take the row where we want a 1. Now we're only going to be changing row 3 here. So we write that down. We copy over those first 2 rows. Exactly. So we're going to take the row where we want a 1. We want a 1 in row 3 and write it down. And then we're going to multiply by the reciprocal of that element. How do we get the reciprocal of 2? 2 is really 2 over 1. We just flip that over and get 1/2. And then we take row 3 of this previous matrix and multiply every element by 1/2. 1/2 times 0 is 0. 1/2 times this 0 is 0. 1/2 times 2 is 1. 1/2 times -6, or you can consider it -6 divided by 2 is -3. Our matrix now has the structure that we want. So what we do is we convert each one of these rows to an equation. This would be x minus y plus 0z, so it's x minus y equals 4. This one is y minus z equals 3. This one is z equals a -3. Now we're going to back substitute and state our answer as an ordered pair. The first thing we can do is put in -3 for z. It's x, y, z in alphabetical order. So let's put in -3 for z. Then we're going to back substitute. We're going to plug in this -3 for z in this equation. We then have y minus a -3 equals 3. That means y plus 3 equals 3. Subtracting 3 from each side gives us y equals 0, and we can put that in as the y coordinate in our ordered pair. We also take this y equals 0, and we put 0 in for y into this equation, giving us x minus 0 equals 4. X minus 0 is x, so we have x equals 4, and we put that in our first position of our ordered pair. As always, feel free to contact me with any questions you have or any comments you have as well. I look forward to talking with you and helping you with whatever you need me to help you with. Have a great day.